Okay, let's see my final project. I choose Appendix D, Workers' Compensation Indication. The first sheet is premium. The column 1, column 2, and column 6 is given. And what we should compute is what we should calculate is column 3, column 5, and column 8. We can say column 3 is factor to current wage level, and it converts the annual change into cumulative factors, such that the factor for the most recent accident year period is indexed to 1. So um, it is equal to 1 plus annual payroll level change multiply the next year's factor to current wage level. In this case, we can choose the year 2016 at the baseline, so it equal to 1, and um, and 2015, 2014, 2013, 2012, all have this base. Yes, all have this base. So we can use this formula um, to compute the factor to current wage level. And the column 4 is expected future wage level change. It is the wage increase expected between the most recent historic period and the time the rates are to be effect. And we choose 6.1% because it is based on an assumed trend of 3% for 2 years. It is equal to 1.03 multiply 1.003 minus 1. So so this is what we choose, and the column 5 is equal to factor to current wage level multiply 1 plus expected future wage level change. And the column 7 is the expected average experience modification. It shows the experience modification factor expected during the project period. Um, these factors are determined via a separate study. So we can get a so I choose 0.97, and the column 8 is projected loss cost premium. It combines the exposure trend and experience modification adjustments to calculate the projected loss cost premium. So it is equal to industry loss cost premium multiply factor to adjust to future wage level multiply expected average experience modification and divided by historical average experience modification. And the row 10 is the total amount of industrial loss cost premium and projected loss cost premium. Okay, let's go to the next part. The next part is indemnity. The sheet 2, sheet 3, sheet 4 is indemnity. So the sheet 2 is reported indemnity loss development, and the first sheet is about H2H development in months. This sheet displays the reported link ratios by accident year for indemnity losses, starting with 12 to 24 months link ratios and progressing through to the 336 to 348 amongst link ratios. So all the numbers is given. So but well, we should calculate the 3-year average expected excluding high low and cumulative. And the 3-year average is means that we should use um, uh, the 3-year average is means that we should use the most closely 3-year to calculate the average number. For example, for the first column, we should use 2015, 2014, and 2013. These 3 years number to calculate the average number. So the average number is 1.4545, and the second column we should use the 2014, 2013, and 2012 years number to calculate the 3-year average. So this rule is all use the same formula, but only choose the different number. And the average excluding high low, it means that we should use the all the ratio in this column, but excluding the highest ratio and the lowest ratio, and then to calculate the average number for other ratios. For example, for column 1, we should excluding the 1.952 and 1.448 and divided by 7. So we can calculate the answer is 1.792. Yes, and the selected link ratios are based on the average excluding the highest and the lowest link ratios. So the selected number is equal to the average excluding high-low ratios. And the tail factor is based on a separate study. The tail factor represents the development expected beyond 348 months. In this example, the reported losses are expected to reach their ultimate level by 348 months. So the tail factor is set to 1. And the cumulative ratio means that cumulative ratio is calculated as the product of all subsequent selected link ratios and the tail factor. For example, the 36 to ultimate factor is the product of all the selected link ratios between and including 36 to 48 months and 336 to 348 months multiplied by the selected tail factor. So this is all the answer. And sheet 3, the indemnity 2, it shows the indemnity benefit cost level factors, and column 1 benefit level change, and column 2 annual on benefits due to which inflation is given. So we should calculate the column 3 and column 4. And first or the last row for uh, column 2 is the expected increase in benefits due to wage increase that will occur between the historical period and the projected period. The selection is based on an estimated 1% trend for 2 years. And the last row for column 1 includes any no changes in benefits that occur after the experience period, which is 0%. And column 3 is the combined impact of both benefit level changes and wage inflation. So it is equal to 1 point benefit level change multiply 1 point annual on benefits due to wage inflation and minus 1. The column 4 calculates the factor needed to adjust each historical accident year's reported losses to the projected level, and it is equal to 1 plus combined impact on benefits multiply the next year of factor to adjust the indemnity benefits to projected cost level. So at this column, we should choose a baseline. The baseline is one. So and we can assume that the 2017 is 1. So the 2016 is 1.02. And then we can get indemnity 3, the loss ratios indemnity losses only. And in this sheet, the column 2 reported indemnity losses is given, so we should calculate all other columns. And the first column is projected loss cost premium, and this number is the same as a premium sheet. It is a projected loss cost premium. Yes, so it is the same number. And the column 3 and column 4 display the loss development and benefit cost level adjustment factors calculated in the period 2 sheets. So we can see the column 3 is from the indemnity 1, and the column 4 is from the indemnity 2. The column 5 is projected ultimate indemnity losses, and it is a product of column 2 through 4. So it is equal to the reported indemnity losses multiply indemnity loss development factor multiply factor to adjust the indemnity benefits to projected cost. And the column 6 is the ratio of the ultimate projected losses in column 5 divided by project premium in column 1. So it is equal to projected ultimate indemnity losses divided by projected loss cost premium. And the last row is the total amount. So we can see the total amount of projected loss cost premium, reported indemnity losses, projected ultimate indemnity losses, and expected indemnity loss ratio. Oh, the last row of expected indemnity loss ratio is the average number of all the loss ratios. The next part is medical. It has 3 sheets. It has 3 sheets. The first sheet represents the development triangle for the reported medical losses by accident year. It is organized in the same way as described in the indemnity loss development selection. So this ratio is all are given. It is based on the all-year average based on the age-to-age development, and the 3-year average and average excluding high-low. we use the same way to calculate as uh, a number in indemnity sheet. So and and it is same that the selected factors are based on the all-year average, excluding the highest and the lowest factor. So the selected ratio is equal to average, excluding highest and the lowest ratios. And the selected and because unlike indemnity losses, the reported medical losses in this example are expected to develop beyond 348 months. So the tail factor is greater than 1. Yes, is greater than the number at indemnity sheet. And the cumulative number we use the same way as indemnity sheet. So it is mm, it is calculated as a product of all subsequent selected link ratios and the tail factor. And we can see the medical sheet 2. It is medical benefit cost level factors. In this sheet, the column 1 and column 2 is given, so we should calculate the column 4 and column 5. The column 3 shows the selected percentages of medical losses by accident year assumed to be subject to the fee schedule. These percentages and their complements are used as weights to combine the changes in column 2 and the changes in column 3. The result is combined effect in column 4. Column 5 converts the changes in column 4 into the factors needed to adjust the historical accident year reported medical losses to the projected loss cost levels. So, and the so we can see the combined effect is equal to medical schedule change multiply annual other medical level change plus portion. Oh, no. The combined effect is equal to medical schedule change uh, multiply portion of medical losses subject to fee schedules minus annual other medical level change multiply 1 minus portion of medical losses subject to fee schedules. And in the medical 3 sheet, the column 2 is given. So, but this sheet calculates the expected medical loss ratios for each accident year in the experiment period. And um, we can see that the calculations are the same as described in the indemnity loss ratio sheet. So I will show you the formula of each column. The first column is from the premium, and the column 5 is equal to um, reported medical losses multiply medical loss development multiply factor to adjust medical benefits to project cost. And the column 3 and the column 3 is from the uh, medical 1 sheet, and the column 4 is from the medical sheet 2. And the expected medical loss ratio is equal to projected ultimate medical losses divided by projected loss cost premium. And the last row of column 1, column 2, column 5 is equal to the average number, and the column 6, the last row of column 6 is equal to the last row of column 1, column 2, and column 5 is equal to the total number of the column, and the last row of column 6 is equal to the average number of this column. Okay, the fourth part is the LAE part. The first sheet is paid allocated loss adjustment expense development, and the same. This sheet represents the developed triangle for paid allocated loss adjustment expense by accident year, and is organized in the same way as described in the indemnity loss development selection. So these all ratios are given, and the same that the selected factors are based on all year average, excluding the highest and the lowest factors. So yes, we can see the selected factor is equal to the average excluding highest and lowest ratios, and the 3-year average factor ratios and the average excluding high-low ratios calculation is the same as we calculated at medical one sheet and indemnity one sheet. And the selected tail factor in this example, we paid allocated loss adjustment expense are expected to develop beyond 348 months. So this tail factor is also greater than 1. So it is equal to the number in medical one sheet, but it's not equal to the one in indemnity one sheet. And the cumulative factor is also has the same calculation with medical one sheet and indemnity one sheet. And the LAE2 sheet calculates the ratio of ultimate allocated loss or adjusted expense to ultimate projected losses. And in this sheet, the column 2 is given. So the sum of the projected ultimate indemnity and medical losses is displayed in column 1. And it is equal to the medical three projected ultimate medical losses plus the indemnity 3 sheet the projected ultimate indemnity losses. And the allocated loss or adjusted expense development factor is equal to the cumulative ratios at loss adjusted expense one sheet. So and the ultimate allocated loss adjusted expense is equal to paid allocated loss adjusted expense multiply allocated loss adjusted expense development factor, and the allocated loss adjustment expense ratio is equal to ultimate allocated loss adjusted expense divided by projected ultimate indemnity and medical losses. And the last row of column 1, column 2, column 4 is the sum number of this column, but the last row of column 5 is equal to 11.6%, and it is the selected ratio we can see in column 6, because it is based on the all year average, so it is average ratio. And the loss adjusted expense three sheet is unallocated loss adjusted expense ratio. And in this sheet, the column 1 and column 2 is given, so we should compute the column 3. The column 3 uh, is equal to the calendar year paid allocated loss adjusted expense divided by calendar year paid indemnity and medical losses. This percentage are the basis of the selection included in row 4. The selection is based on the latest 2 years, so we should see the 9% number is equal to the average of year 2015 and 2016, because the actuary expects those years to be more representative of the future. And the last row, the total row of column 1 and column 2 is the sum number of this column, and the total row of column 3 is the average number of this column. Okay, the next sheet is indication. And this exhibit brings together the results from the previous exhibits and calculates the indicated loss cost premium change. So the column 1 is expected indemnity loss ratios. It is from the indemnity 3 sheet, and column 2 is expected medical loss ratio. Uh, okay, we changed. We use another type of the numbers. Use percentage to show clearly, and the expected medical loss ratio is from the medical 3 sheet, and the expected allocated loss adjusted expense ratio is from the loss adjusted expense 2 sheet, and we choose the selected ratio. And the expected unallocated loss adjusted expense ratio is from the loss adjusted expense 3 sheet, and we also choose the selected ratios. And expected loss and the loss adjusted expense ratio is equal to expected indemnity loss ratio plus expected medical loss ratios multiply 1 plus expected allocated loss adjusted expense ratio plus expected unallocated loss adjusted expected ratio. And the 6 selected is equal to 100 100 110.8%. It is based on the 5-year weight average. So we can see this one. It is equal to this one, and the indication is 10.8 percentage. As the objective of the analysis is to determine the advisory loss cost, the premium does not include any underwriting expenses or profit. Therefore, the target loss ratio is 100%. So this indication percent is equal to selected percent minus 1. And the last part is companion. Uh, Companion sheet. This sheet is companion adjustment. And the row 1 through 4 shows the expected underwriting expense as a percentage of total premium for each major expense category. And the row 5 is the target profit as a percentage of total premium. Row 6 is the total of the expense and profit percentages. Row 7 is calculated as a reciprocal of 1 minus the total expense and profit percentage. This adjustment applies multiplicativity to the advisory loss costs to include a provision for underwriting expenses and profit. Row 8 displays the expected difference in loss costs due to any known operational differences between the individual company and the industry. In this case, an overall average adjustment of minus 5% was selected to reflect an expectation of lower losses attributable to the company's more stringent underwriting and claims handling practices. The selection is converted into a factor in row 9. The row 11 The row 10 combines the adjustment for expenses and profit with the adjustment for operational differences. This figure represents the deviation factor that the company should apply to the industrial advisory loss costs. Row 11 is the current company deviation factor, and row 12 is the industrial loss cost change. It is from the indication sheet. And the row 13 combines the change in deviation factors and the loss cost change to calculate the indicated rate change for the company. It is equal to the proposed deviation divided by divided by current deviation. Multiply 1 plus industrial loss cost change and minus 1. This assumes that the company's distribution of risks is similar to the industry distribution, and that the industrial loss cost change applies uniformly to all risks. If that is not the case, the actual impact for the company may be different from the industrial loss cost change. Okay, this is my project. Thank you very much.